You're gonna have to just ignore my address bar because my screen goes black whenever I full screen. I'm Adell Hanson-Kahn, and I'm a software engineer at Airbnb on our native infrastructure team, which isn't really like native libraries, it's just Android and iOS libraries. This will be a begin-to-intermediate-ish talk on one simple but powerful component of our overall modularization strategy, which is our plugin integration points or plugin architecture. Sweet. So imagine that you are a product engineer working at a flourishing and stylish chair-sharing software marketplace called ChairShare. And some people provide chairs and other people pay to sit in them. As discussed, the company is flourishing. And you as the CEO, sorry, you're not the CEO, but your CEO wants you to continue to have a great valuation multiple. And so you expand into an adjacent but supplementary vertical. You want to provide new functionality for this product into your existing Android app. So you have an opportunity here to demonstrate some impact as well as reuse some code. For this talk, all arrows will demonstrate access. So right now, this one app can access both of these features. Fortunately, ChairShare has made investments in a robust platform architecture so that we can reuse our base infrastructure when adding new features or expanding into new businesses. Does anyone have a guess what the boxes around the different icons represent? Nailed it. Modularization. So the little boxes are modules, and in general, what are the broad benefits of modularization? Reuse, build speed, anything else? Separation of concern, clearness of code, and decoupling, yeah, encapsulation. And also at Airbnb specifically, modules become a unit of ownership. So a team will own one or many modules, but there can only be one owning team. And then what are the main challenges around modularization? Naming. Dependency management. That's like the biggest thing. So managing your dependencies in order to capture all of these benefits is definitely the hardest part of modularization. In our case, ChairShare and CornerCap's feature modules will depend on our base module. And this is also going to be like Gradle heavy. So these are examples. The comments represent the module, the package, and then also the corresponding module that would host like a Gradle file, and then that's how you would depend. So we talked about modularization giving a build speed improvement. Does anyone know how that actually works in our build tooling with most common build tools? Caching? Right. So the output of the base modules here can be cached, and then changes to the feature modules will not impact the cache. In Gradle, that's like Gradle tasks, but most tools like Buck or Gradle, Bazel, they all support this. And this is also the thesis of incremental build support. So then let's return to the hard part, the dependency management. Imagine you have a search screen and module, which depends on our base module. We want to show results from both features in our search, so we can add them as dependencies to search. And then we can draw the rows in our search results. Imagine you have like some DSL for rendering rows. Now here, note here that building the search module requires recompiling if CornerCaps or ChairShare modules change. Additionally, remember how we packaged the ChairShare and CornerCaps features into the same app? What if we don't want to add a new, or what if we want to add a new app that uses search but doesn't use ChairShare or CornerCaps? So here you can see that with each new feature that uses search, it adds a new dependency to search. And additionally, if you recall our code sample from earlier, we hard-coded the feature rows. So we could use branching logic here, but as you'd imagine, that isn't going to scale very well as you add more and more features. you'll get more and more product-specific code into your like platform-level modules, and then you'll be tightly coupled to them, which is the whole point of modularization. So does anyone have a suggestion how we can reverse out of this ugly situation? Yes, go on. You nailed it. So this is basically the thesis here, but you can use an interface, polymorphism, and we have to put that interface in a different module so that we don't get a circular dependency. This is what it would really look like. What we'd really want is for the search feature to be at the same level as the contributing modules, like in this diagram, and we can power this cross-module interface with a Dagger feature called multibinding. Multibinding generally allows you to declare a map or set and then collect elements at runtime from our dependency graph without having a direct dependency on the providing like the things that provide the actual elements. In this case, that's the rows from our ironing feature and sharing corner caps. Right, so the thesis of our plugin architecture. So then this is what it would look like in Gradle for configuration. And this is how we would recapture, like I said, composability, or like you said actually, composability, encapsulation, and incremental builds. It is becoming like a little bit tricky here. We only have 3 features, 1 platform, and then like our base modules. Imagine that you have hundreds of features and like many platforms, and then like a bigger and bigger base modules. It would be difficult. You know, imagine now that you're a infrastructure engineer and you want people to be able to still join the company and contribute and be able to set up their own modules, because every team is going to have multiple modules that they own. But you don't want them to have to like experience what you just went through, and also you don't want them to break things. How could you make sure that people are still empowered and enabled to contribute without breaking your module dependency management? Okay, so you could maintain them, I think, yourself. So this person said that they maintain the artifacts themselves, and they publish them, and then they're shared as well as like consolidated, and they work together. That's one way. What if you want people to be able to self-service? You could have like a CI job to check, do some static analysis. Right. So you could do either of these things. You could maintain it yourself. You could run checks at PR time. You could run them periodically on a cron job. What we do is we communicate through the language of love, which is compile time errors. But I think this is probably the fastest like feedback loop. It allows you to not really, as a product engineer, have to know like super much about what's happening, just like give you a helpful error and then tell you what to do. So we formalize this architecture pattern, and we enforce it pre-merge. But some things we also like throw compile errors. So these are the different things that we can enforce pre-commit. We can for each module type, you have like a few rules about like what it can contain. Generally, like a library module doesn't have UI in it. So at a very like rough description, if you have something that like inherits from fragment in a library, it's probably UI and it probably doesn't belong there. You can also whitelist things, so maybe you have like a special case. The prefix, someone said module naming is hard. You're right, module naming is hard. And so you want things to be consistent. We use prefixes of feat and lib for these 2 module types. And then also, most importantly, the dependencies that are allowed for a given module. So libraries can depend on base and library only, and then features can depend on the same things that libraries can depend on. Features cannot depend on other features, otherwise they'll become too tightly coupled, and like a change in one feature will cascade outward, and you'll have bad build times again. In general, a feature will have some UI in it, like a single screen or a flow of screens, and then a library will contain either some shared logic or just, like we talked about earlier with the search interface, some like hook for other things to like attach itself to. This is what multi-binding would look like if you were doing a recycler view and we had like our share rows. You can see you don't actually need to declare the map. Dagger will provision one for you if you didn't like set it up, but you do need to like specify that you're adding elements into like a specific thing, and it'll look at the signature, or you can do like naming to make them differentiated. You can, I think most important, if you look in the constructor for search fragment list adapter, I guess I should probably walk you through this from the top. So you like provide like inject annotated constructors so that Dagger both knows how to like instantiate something as well as it will like hydrate it with all of its dependencies. That's like the topmost row of share row, and that would belong in the share feature. And then you can, within that same module, you would bind that element into the multi-binding. And then at the sort of platform level of feed search, which is still a feature in this example, you can then consume it by passing in your list or your map of rows. Also, if you're a very thoughtful person, you'll provide like a default in case something doesn't map well to something else. Oh, here. So does this work? If you have this set up, will you get a share row in your recycler view adapter? He said probably not, because it shares a share row instead of a search row. Exactly right. So here the implied return type is going to be the more specific share row. Kotlin's being very helpful to you. But we're going to end up with one map of one element of share row, and then it's not going to be present in the more generic map of search row. So you could specify this explicitly, and then this would be fine. But that's like it's a common gotcha, and like if you're not very good at Dagger, or you like use something else typically, then this isn't going to be very good for you. So we realized that as we were using this pattern over a couple of months, that we could simplify it with our own annotation processor and the custom annotations app plugin and plugin point. We use app plugin point to declare a multi-binding collection, and then we use app plugin to add an element into an existing collection. And you need both, and we'll throw a compile time error if you don't have a plugin point. You also like need to specify the plugin point in the value of your annotation, so you can't make that error anymore. So some of the benefits of our annotation processor supported plugin architecture are that, like we mentioned, compile time checks. You can make sure the plugin is configured properly. Generally, it's easier to use without strong Dagger knowledge. It conforms to like this overall plugin integration point idea from like a previous platform vision that Airbnb like did in 2018, and then it's easier to pattern match. You can just find other examples of plugins or plugin points, and if you want to add a new one, you just like copy and paste the old one, or read the documentation. But either one. Sweet. So then this is like how it actually works. You start with your like Oh, so we register like for rounds of annotation processing, and then we generate like intermediate um, Dagger annotations. So it's really just going to be like multi-binds again, and then we can consume them. And then some things that are really important to mention here are that we have a unified Dagger system. You don't need this in order to use multi-binding or like a plugin-based system, but I think that it makes it a lot more powerful for us. And so this is generated with a Ruby script. You could use like an IntelliJ plugin, but for now we use Ruby scripts for every new module that you set up. This and like a bunch of other things like feature flags and logging and stuff like that. And then within the realm of intermediate annotations for Dagger, we have, so my favorite engineer at Airbnb, who's also my mentor, his name is Ben Schwab. You can tweet at him if you want this for yourself. But he wrote this intermediate annotation processor called Scabbard that goes with Dagger. And it generates like really gnarly code that you wouldn't want to have to like manage yourself or reorder. I blurred out some things. They probably weren't sensitive, but just to be safe. And this file is like half of the file. It's 2,000 lines long, and then it keeps going. This one like extends list is like many monitors long. And if you would imagine like having to like order this yourself, that's like the whole point of dependency injection libraries like Dagger, is that you don't have to manage the ordering and like resolution of your dependencies. Here, you also like it becomes difficult to manage using Dagger in a very large number of modules. And so the plugin annotation processor is actually now just like one of the rounds that we use within the overall Scabbard system. But it's a little more complex, and you probably don't need it unless you have hundreds of modules. Sweet. So a quick reflection on how we use the plugin system. It allows a base level module or like a platform module to expose some hooks, and then other things can hook into it. So more specifically, you can co-locate like the most specific part of a piece of infrastructure with its feature or screen. So like one example would be deep links. You can put the deep link in the same module as the screen that it resolves to, but it still gets to hook into like the base deep linking infrastructure, which is exposing a plugin point of like deep link loaders or something. Same thing with like feature flags or something else is like post login actions. Like maybe you want to like load something for one experiment from some specific feature module that you spun out specifically for the experiment, but you want to do it like after login is complete, only for like authenticated users without like interfering with initial startup. You can do that all from like the same module. And that's it. I cannot take your questions over the microphone because we are in a quiet period at Airbnb, but I'll talk to you in person.